All right. So let me quickly share my screen and be sure you all can see my screen. Okay, so host disabled participant sharing. Hello, can you give me access to share? Hello, Mercy, are you there?
Yes, I'm here. I think he is already. I'm coming. Hold on, please.
All right.
Yeah, please try again. Sorry.
All right. All right. All right. So, share. So, can you see my screen?
Yes.
Yes.
How big it is? How big?
I think you should enlarge it. Like,
Yeah, enlarge it so that I can cover the screen. Your screen. Yeah.
very
Yes.
better.
All right. All right. So before we start today, I would like to do let's just let me hear from you what you learned in the last workshop, because whatever we are going to be doing today is heavily dependent on your last workshop. So if you're still having issues, or maybe you're still struggling with understanding some concept treated in the last workshop, whatever we are going to be doing today will be a bit more confusing. So I don't know, is there anything in your last section that you didn't understand? Maybe you don't understand the concept. We can just quickly touch on it before we proceed. Okay. Okay. All right. I presume everybody understood what happened last section. All right. So if you notice, our slide is not much. We just have 6 slides. So we'll be doing more of writing smart contracts today. And just touch through some theoretical stuff before we dive in. So let's go ahead. So today we'll be dealing with writing smart contracts. For those that maybe you're joining for the first time today, my name is Kasri, and yeah, my Twitter handle is Coding Cas. All right, so let's dive in. All right, so we have let me make this a slide. Sorry. Hope you guys can see. You can see this clearly. Do I need to make it a slideshow? Hello, can you hear me?
Yeah.
Yes, I think you can make it a slideshow to make it more better.
All
For
right.
people using their phone.
Okay. I'm using Google presentation for the first time, actually. All right, so introductory smart contract. All right, I know the main purpose of this whole stuff is for us to start writing smart contracts. And yeah, today you'll be writing your first smart contract for the people who haven't written smart contract before. So introductory smart contract. Smart contracts are simply programs stored on a blockchain that runs when predetermined conditions are met. So they typically are used to automate the execution of an agreement so that all participants can be immediately certain of the outcome without any intermediaries involvement or time loss. They can also automate a workflow, triggering the next action when conditions are met. So smart contracts are just like your normal programming languages, you know, when the particular condition is met, it should do this stuff. If this is met, it should do this stuff, like the if-else statement and all of that. So that's how it is. The difference is that smart contracts are stored on the blockchain. So the codes are stored on the blockchain and they are executed using, for instance, on Ethereum, the smart contract codes are executed on the Ethereum virtual machines. And whatever the variables you write, they are stored on the EVM, that's on the EVM storage and all of that. So, and smart contract works with the principle of if it works with the if-then principle. So if a condition is met, then you do this. That's the principle with which smart contracts work. So it's just programs that are stored on the blockchain and all of that. So on Ethereum virtual machines, smart contracts are written with a programming language called Solidity. It's written with a programming language called Solidity. Solidity is some people will say Solidity is a Turing complete language, while some will say Solidity is a quasi Turing complete language. So I will go with Solidity being quasi Turing complete. So Solidity is not completely Turing complete, it's quasi Turing complete. Yeah, so the reason why it's quasi Turing complete is because if you're executing a function and maybe you run out of gas, everything will fail and all of that. So that's why it's quasi Turing complete. So let's move to the next guy. So the next guy we have inter-contract execution. So smart contracts can interact with other smart contracts in two ways.
One of you can't hear anything.
Is there any other person that can't hear me?
I can hear you clearly.
I think it's your
We
network.
can hear you.
Person that cannot hear, I think it's your network because I can hear him clearly. Maybe you should leave the call and join again.
All
Please,
right.
so that I can hear him. Quite audible, yeah.
All right. So inter-contract execution, smart contracts can interact with other smart contracts in two ways. One is contract inheritance, and the second one is contract interaction using interfaces. So we are going to look at contract inheritance. So contract inheritance is one of the pillars of object orientation, and Solidity supports inheritance between smart contracts. So inheritance is the process of defining multiple contracts that are related to each other through parent-child relationship. So I'll be showing you how you inherit contract in Solidity. So we'll be doing we'll do more of that while we go into practicals. So in other programming languages, you see you have a class, and you see a class inheriting another class. Some will say extends this other class and all of that. So, but in Solidity, when you write a contract, if you want to inherit another contract, you make use of the is keyword. So we'll see more of that while we continue, while we go into practicals. So Solidity also supports contract inheritance. Now for contract interaction using interfaces. So for those of you familiar with object-oriented programming terminologies, there's what we call interfaces. So interfaces in other programming languages, whereby maybe you declare a function in your interface, You don't write the logic of that function. You only declare the function and the argument. Now, when you implement that interface in a class, it enforces that you have to write all the functions that were declared in that interface. So it's that same thing. That's how it also works in Solidity. But in Solidity, it works two ways. So you can use interface for either implementation or interaction. So if you're using interface for implementation, that means when you're going to inherit the interface in your contract, and you have to write all the functions that were declared in that interface. But what we are talking about here is not interface for implementation. We are talking about interface for interaction. So with an interface, you can interact with another smart contract that has been deployed without inheriting it inside your own contract. So for what we have here, contract interfaces contains all the methods we want to interact with. We want to interact with from the original contract, but instead of having the full code of each function, they only include the function declaration, name, parameters, visibility, and value return. Interfaces do not include the function body. Just like I said, they don't include the logic in the function. You just declare them and you make use of them. So we'll see more of that while we start the practical. So when you are working with several smart contracts, you'll be faced with interfaces. Interfaces gives you the possibility to interact with other smart contracts without inheriting them. Yeah, just like I said, you can interact with other smart contracts without inheriting them using interfaces. So let's move to the next guy. So Solidity library. So a Solidity library is a standalone entity that looks similar to a contract, but is strictly not a contract. You can't declare a state variable or send ether in a library. Libraries are mostly used to create simple helper functions. The library is embedded into the contract if all the library functions are internal. Otherwise, the library must be deployed and then linked before the contract is deployed. So now, when declaring a library, when you write a function in a library, the functions are mostly internal functions. That means they use the internal function visibility. But whenever you make use of the external or public function visibility, that means you have to deploy the library separately before using it in your contract. And in my experience as a smart contract developer, I've not used external deployed library. All I'll be using are libraries that have been inherited. So that means the libraries I'll be using are the libraries with internal functions, not the one with external or public functions. So yeah, most of these things, while we start writing smart contract, we'll be seeing a lot of them, and you see how they are being used. All right. So let's continue. Okay, so the next thing we have here is smart contract design pattern. So smart contract design pattern simply refers to how a smart contract developer chooses to design the flow of their logic. So for instance, there are some smart contract codes you see that events are written at the bottom of the file. Some persons write events at the top of the file. Some persons choose to write modifiers at the top of the file. That's before the inside the contract block. Some person chooses to write it at the bottom of the file. So it depends on how you structure your file or your code. And also the smart contract design pattern is also dependent on how you are able to think about your logic. So there are some problems you want to solve. Some persons will choose to use arrays to solve certain problems. Some persons will choose to use mapping to solve certain problems. And some persons, so different logic, different implementation pattern depends on how the developer chooses to think about it. I don't know if you get. So that's why there's a saying that a contract is as smart as a developer who wrote the code. So if your contract is not smart, that means the developer is not smart. So try to be smart so you write smart contracts that are smart and all of that. So yeah, Yeah, so that's basically what you basically refer to as smart contract design pattern. But I'll be showing you different smart contract design pattern as we continue to work. So when I was learning smart contract, there's this guy that was always teaching us. His name is Timmy Dan. So you'll be like, when he gives us a problem, you'll be like, you choose your design logic, choose your logic, and work with it. So at the end of the day, when he goes through everybody's code, he will be like, okay, this logic will cost more gas, this logic will cost less gas, and all of that. So you learn better ways of writing smart contract, but at the end of the day, the design pattern is based on the developer and all of that. So yeah, before we dive into more practical smart contract writing, let me take some questions before we move in. All right, any question? Hello, everywhere is quiet. Can you hear me?
Yeah, we can, Cass.
All right. Okay, so let's go into the main activity of the day, which is writing smart contracts. So so this is what I want to do. We are going to go from simple, so we are going to progress in level of complexity. So we are going to go from simple smart contract to medium smart contract to a more, we are not going to write a very cumbersome or complex smart contract, but there will be an increased level of complexity as we go. So we are going to be writing 3 different smart contracts today. So it will help us understand certain things, and while I write the code, I'll also be explaining certain things as well. All right, and while we'll be writing the smart contract, please, if you have any question, don't wait till the end. Just now we are dealing with code, so ask the question why we are writing, so I can quickly explain and move ahead. All right, so the first contract we are going to be writing is a simple mood changer contract. So this contract will help us to understand how to write to storage and how to read from storage. So that's why we'll be starting with this and all of that. So I believe, so if for writing smart contract, there is a text editor that's an online text editor called Remix. So just open remix.ethereum.org. So with this, let me paste it in the chat section. So with this, you should be able to, okay. With this, wait. Okay, someone asked the question, please, what are the tools and software to install in order to write smart contracts? All right, in order to write smart contracts, you need, let me just write them here. You need, first of all, you need to have NPM in your system, that's Node.js. So once you have Node.js in your system, should be good to go, because every other thing will be dependent on NPM. So use NPM install this to install the rest of the stuff we need. But for now, let's just start with Remix. So I will be pasting this URL here. So this is remix.ethereum.org. And yeah. So before we move ahead, now we talked about library. Can you see my screen? Should I increase this more? Should I increase this?
Yeah, we can increase it.
All right. Let me know if it's okay. Is it okay?
Yeah, I believe it's fine. I believe this is okay.
All right. So at first we talked about let me just go through what we did here. So we talked about Solidity libraries. So let me show you what a library look like. So this is a library. I called it lib here. So you see, this library, when you're writing the library, you start with library keyword. You give the name of the library. And here I wrote a function, and the name of this function, I called it add. So what this library does, it will handle basic mathematical operations. So this function basically will take in two values, and both of them are unsigned integers, A and B. It's an internal function, it's a pure function. It returns an unsigned integer as well. So all it do is it returns A plus B. This is so this is just a helper function that I will use anywhere I want to make use of this, maybe anywhere I want to perform an addition operation between two numbers. So if you see, there are two ways to make use of a library in Solidity. So this is the first way to make use of it. You import the library first. So this is why I'm importing the library. Look at the name here, lib here. I'm importing it here, lib here.so. And once you import this library, you have access to the library automatically. So after importing it, I now wrote my contract. The name of my contract is implement math. So function add. So my function is taking two parameters. That's this number and this number. And it's returning a uint as well. And here I'm declaring the value, the return value here. So when you're declaring the return value here, you don't need to use return again. All you just need to do is set the value equal to. Now, we have imported our library. So now the name of our library is math. So all I just need to do is math here dot the function in the library we want to make use of. Then I pass in my guys here. Once I pass this guy, it's going to return this value for me. And that's how to make use of a library. So this is just one example of how to make use of a library. There are different ways you can make use of libraries. There are code bases I'll show you. You see a whole lot of functions, and they are all written in libraries. So this is the second way to make use of a library. So here you make use of the using keyword, and you say using math for uint. So you see that the way we did this is different from the way we did this. So what I did here, I took the first parameter, the second parameter, and I returned a.add the second parameter. So this is the second way to make use of a library in Solidity. I can also remove this return here, and I can say, I can give this a value, return value. I can call it value. So here I will just do value, I will just do value is equal to this. So once you name you give your return value a name, you can just call that name and set it equal to this, and it will still work perfectly well. So, or you can remove this and pass in your return here and do your return here, and everything will still work very well. So why is this guy giving me invalid input source specified? Free this guy. So this is how to make use of a library in Solidity. So one of the reasons why I don't really like explaining things like library interfaces and all of that is because if you explain them before actually writing the contract, it gets confusing. So when you write more smart contracts, you see the uses and how useful all these guys are along the line. So now let's move into the main stuff. So I need to create a folder here. I'll call this folder Web3 Afrika. So it will contain everything we are going to be doing today. Web3 Afrika. So inside this folder, the first thing we are going to do, I want to create a file, and I'll call this file mood.sol. So Solidity files have the extension SOL. So anything you create, you save it with .sol. So now this is how we have a clear text editor on Remix to write our contract. So when you want to write a contract, the first thing you need to do is to specify your license identifier. So this license identifier is just like the normal. If you have made use of GitHub, where you put your license and all of that, you have the MIT license. You can put on license, different types of license identifier.
Yeah, excuse me, sorry.
Yeah.
Thank you so much. Please, can you zoom in a little bit, like zoom in your browser tab?
Okay.
Yeah, I think so. Yeah.
Okay.
So the code should be a little bit clearer now.
All right. All right. So yeah. So the first thing we need to do is to license identifier. Let's go with we want to do so to specify your license identifier, make use of xpdx license identifier.
There is a question though. It says, what's the purpose of the identifier?
So the license identifier just tells the compiler the kind of license you're using. So there are different license. There are different license. How would I explain this guy? Just like the GitHub license. Maybe you're telling someone that, okay, this contract is using this particular kind of license, you can use it, you cannot, different license for different stuffs and all of that. So it's just to tell your compiler or to tell users that, okay, this file is under this particular kind of license. And I think it's from Solidity 0.8 that they implemented this license identifier stuff, where you have to impute license and all of that, but it's just to tell the file and the compiler that, okay, this code is making use of a particular kind of license and all of that. Do you get that?
Yeah, clear.
All right. So this is how you declare your license identifier. I start with xpdx. So this stuff is I've never really tried to understand the meaning of xpdx and all of that, but see this as something similar to when you're writing your HTML, where you have something like meta, character set, UTF-8, all those kind of things. You just know this thing needs to be there to tell this code that, okay, this thing is using this type of character set and all of that. So that is how this is. When you use character set UTF-8, you're telling it that, okay, this is HTML5 and all of that. All those kind of stuff you just need to add. So that's what this license identifier is. You just need to add it to your smart contract, and for compiler to know that, okay, this is using this license. You can either use on license as well, or I always make use of MIT. So I always make use of MIT. I don't think I've ever used on license. So the next thing you need to do is you declare your pragma statement, pragma solidity. And this pragma solidity tells Solidity the version of Solidity that this file will be using. So it tells the compiler, that the version of Solidity that this particular Solidity file will be using. So there are different ways to declare pragma Solidity version, but a lot of times, in order to avoid compiler issues, we like making use of this guy. So use 0.8.0. So this tells the compiler that from 0.8.0 upwards to maybe 0.8.17, which is the latest, the highest and the latest Solidity version. So that's what this means. So anything from 0.8.0 upwards, it's this compiler will compile it and all of that. So that's what that caret means. That caret sign means 0.8.0 upwards. It should compile the file and all of that. So there are other ways to do this, guy. You can do equal to. So this will tell Solidity that it should strictly use 0.8.0 and all of that. But a lot of times I make use of this. So because I just want to avoid compiler errors and all of that. So we are using Remix. A lot of time, Remix takes some time to compile, and once that is happening, you see this stuff, this error, and so it's auto compiling and it gives you some error while that is happening. So, and if this happens, most times I like to reload so that everything will be working well. So I think I will just reload this guy for everything to come back normally. Okay, so let's wait for it to load.
Yeah, while we wait, please, there's a question.
Okay, so, okay, because all contracts are visible on Ethereum, provided you know the address, it's important to know how it's licensed. Okay, it is a proprietary or open source contract. MIT license are usually open source. Yeah, so why is it that anytime you're declaring, you are declaring, you use a mix of lowercase and uppercase letters? Is it something that's necessary, like case sensitive, or is a semantic thing? Okay, it's a semantic thing. That's how it's written. It's a semantic thing. So for only the XPDX is what you write or with all capital letters. So after the XPDX, that's after the colon, the license, the L is capital letter dash, the identifier, the I is capital letter. So that's how it is. That's how it's being written. If you write it in any other way, the compiler might throw an error. So it's just semantic. That's how it is. So let's wait for this guy to come up.
Okay, I think someone is raising their hand.
Okay, they should go ahead. The person raising their hand.
I hope it was clear what I said in the messages. That was a statement. It wasn't a question. With regards to the licensing.
Yeah. It's clear.
Okay, sure.
All right. So we are done with the SPDS and the Pragma Solidity. So now we are not importing anything.
Please.
Normally.
Please zoom in again.
Oh, okay, yeah, that's true. All right. So normally, if you have anything we want to import, we make use of the import statement here. And if the file is within our contract, we can do something like this / the name of the file, and but we'll see more of import while we proceed. So now we have declared our license identifier, and we have declared our Pragma Solidity statement, which tells us about the Solidity version we want to be using in this file. So the next thing we do is to write our contract. So once you write your contract, you give it a name. So normally convention is that the contract, the name of the contract should start with a capital letter. Yeah, so now we want this contract to, we want to call it mood, and we give it this guy, all of that. So you can call this any other thing. You can call it mood contract. You can call it mood swing, anything you want to call it. But normally, I like maintaining that the name of my contract is also the name of my file. So this will help me if I'm dealing with a lot of contracts, right? And I want to quickly so if you're working with things like hard hat, if you're working with hard hat and you're inheriting a contract, most of the times people confuse this file name with the contract name. Now, what you're inheriting is not actually the file name. What you're inheriting is the contract name. But by the time you give this contract mood and you give it mood swing here, when inheriting, you might think you're inheriting the file and you inherit mood, and you run into errors because what you are actually inheriting is not the file, but the contract. So in order to avoid such kind of errors, I like maintaining the same thing like mood. So I know if my brain is telling me that I'm inheriting the file, whichever way still works because the name of the file is also the name of the contract. So now I'm calling this contract. Now, once you declare this contract statement, every other thing about your smart contract goes inside this scope, inside this contract scope, or inside this block. So now we have declared our contract, we have this mood, every other thing comes in here. So now I don't know, in your last workshop, you must have heard about state variables, local variables, and all of that. So blockchain, like we said, is a global database where you write stuff, you write things to state, and you read from state and all of that. Now, this database that we are talking about, this global database we are talking about, and when you hear that, when you write something to the blockchain state, now anything that you declare in your state level, in the state level of your contract, they are being written to the blockchain database or the blockchain storage, and they are permanent. But whatever you write in any variable you declare inside your function, they are temporal. They last as long as that function lasts. So let me explain this. Now, we have different types of data types in Solidity. We have the address. We have, so let me just go to writing this contract because I feel like I'm going back to what you guys did in the last workshop. So now for mood, we need a variable that will be holding our mood. That's the correct mood that we are currently on. So it's like, let's say you have a database where you want to be writing different moods and all of that. So we need like a state variable where we'll be storing our current mood and all of that. So this state variable, we can call it anything, but since what we'll be storing there is a string, so the type of that variable will be string. What's happening here? So the type of this variable will be string, and we want to call it, we'll call it current mood. So now we have declared this variable. So now all variables in Solidity have a default state. Now the default state of string is empty, which is this. The default state of a string is empty. That means it doesn't have anything. The default state of an unsigned integer is 0. The default state of address is address 0. That's 0000 address. So the default state of a bool is false in Solidity. So now declaring this guy like this, we didn't assign any variable to any value to it. So the default state of this current mood is an empty string that it doesn't have anything. And whatever you write to this variable is permanent because it's declared at state level. So this is permanent. This is stored in the blockchain storage. That's the EVM storage. Now, if we declare a function and we call this function set mood, and this function is going to take in an argument of type string, and type string, you have to tell it to be memory, and we want to say, we want to pass in a variable, a parameter called new mood. So, and I'm making this an external function, and an external function, and I'm passing this guy here. So what this is going to do now, I'll now say current mood will now be equal to whatever this guy is setting as our new mood here, and we set this guy. With this, we have written a function that is going to be updating this mood here. Anytime we pass in a parameter, we set this mood to the new mood we are passing here, right? So this is how to. So now here that we have external, this can also be public. So remember I said while we are writing this contract, I'll be explaining some concept and all of that. So this is called function visibility modifier. So there are 4 types of function visibility modifier. There is public, there is external, there is internal, and there is private. So you can only use one at a time. So let me take this guy out of this place. Let me take this guy out of this place and put a comment here for it. And I'll do this comment here. So you can only use one at a time in one function. So whenever you make use of a public, whenever you make use of public in your function, now what it's saying is that this function can be called outside of this contract, and this function can also be called inside this contract and also by any other contract that inherits this smart contract. Is there confusion? I know there's confusion. If there's confusion, ask your question before I proceed. Okay. So now, out of all these function modifiers, these visibility modifiers, the lowest one is private. Now, private, whenever you make use of private in your function, it means that this function can only be called within this smart contract. For instance, if we have another function here called check mood, sorry, let's do function check mood. Now, this function check mood might be an external function, and it's going to call this set mood. I don't know what I'm typing today. It's going to call this set mood, and it's going to pass in a parameter to this set mood. So maybe it will take something like new mood and all of that. So, and for it to pass this parameter to this guy, you must have received a parameter here called string memory. And you call this new mood. So just for this thing, let me add one D to this guy and add another D to this guy. So now you see that this function is calling this function. Now, only this function can only be used, this set mood you're seeing here can only be used inside this smart contract. It cannot be used outside the smart contract. If another contract inherits this mood contract, that contract can't call this private function. But if this function was internal, now internal functions can be used inside the contract where it's declared, and also by a contract that inherits this contract. So if you're getting confused, please let me know, because these things you're saying, they are like the foundation of writing smart contract in Solidity. So if maybe you're not getting it, I can change my explanation pattern for you to get it very well. So now, when you make use of internal, this means that this function can be called inside the contract where it's being declared, and it can also be called by a contract that inherits this contract. For instance, let's say we declare another contract here, and we say, we call this inherit mode, right? And this inherit mode is inheriting mode. Now, this is how you inherit a contract, is mode. Now, once you do this, all the functions that you have inside this mode, you automatically have them inside this inherit mode contract. But the private functions, this inherit mode contract cannot inherit the private functions. So now we can do something like function new updates is equal to, let's say, string memory, and we call this another mode, and this tends to be an external function. So this function now can automatically call this set mode. So we can say set mode, and we pass in another mode here, and this should work. Let's see. So you see that this is working. But if we change this guy to private, this contract won't be able to inherit it. So look at what's happening here. Undeclared identifier. This set mode now, this guy is not seeing it because this guy is a private function. This function can only be used inside the contract where it's being declared, but any contract that inherits this mode contract cannot see this guy because it's private. I don't know if you understand. Please, if you do, just I need to hear your voice. I need to be sure that you guys are following me.
No, like we can get like the explanation behind like the labeling, but if there's anything itself that can cause confusion, especially like to beginners, people that have not started writing Solidity, just like how like you are declaring your functions, but I'm guessing that is something that comes with experience.
Okay,
Yeah,
how I'm declaring my functions.
Yeah, just like how you're writing everything down, like new mode update, string memory, those individual properties and everything.
All right, no problem. So yeah, I'll explain better. I'm just trying to, you know, in this guy, we talked about inheritance. So if you look at this place, we talked about inheritance. So contract inheritance. So I'm trying to touch those things. We already did the theoretical part of them before we actually head on into maybe other stuffs and all of that. So I don't know if you get.
Yeah, I do.
All right. So now, if you understand this whole stuff, so this is how you inherit from a contract. So you see this inherit mode, this is the name of the contract, and it's inheriting this mode contract. That's why you make use of this is here. So inherit mode is mode. And once you do this, you automatically have access to all the functions inside here, apart from the private functions. Apart from the private functions and yeah, all of that. So, but you see now that we change this guy to private, this set mode is throwing an error here because we don't have access to it. So if we make this internal, this should work perfectly well here now. See, the error is no longer there. Now let's look at public. So when we make it public, it also works because public is the highest level of visibility, is the most free and open level of visibility. If a function is public, that means it can be seen outside this contract, and it can also be seen within this contract, and it can also be seen by any contract that inherits the contract where the function is declared. So that's the highest level of visibility for a function. Then let's try external and see if this guy is going to. So now you see, in external, this guy is complaining. This guy is complaining. Now, external functions can only be called outside this contract, but not inside the contract. So when you make a function external, it means that this function can only be called outside this smart contract. You can't call it within this contract. That is what external means. But internal means it can be called inside this contract and also by any contract that inherits it. But external means it can only be called outside, but not inside. So if you see it's working here because this contract is inheriting it and is calling it externally, but here this guy is calling it within this contract, it will not work. So you understand more of these concepts as you keep working with it and you keep digging into it. So let's just finish writing our contract. So I will now explain what everything means. So I'll have to remove this guy. Sorry guys for the lengthy explanation. All right, so let me just leave this guy, or let me take it out so we keep our guy clean. So current mode, set mode is equals to this, and this one. So now we need to write a function that will read from states. So I'll explain everything once I'm done. So function get mode, and this is not taking any parameter because it's a getter function. So we call this external view. It's a view function. So this returns, what is it returning? This returns, it's going to return. Now, what this guy is returning is basically returning this mode, and this mode is a type of string. So we are going to say return string. And since we are dealing with a reference type, we always have to specify the location, which is memory. Sometimes you can make use of core data. So this returns string memory, and we now run something like this, and we now say return. What are we returning? We are returning whatever value that is saved here. So we keep this guy here and we put this guy here. So this should work very well and all of that. So now let me explain what's happening here. Let me start from the beginning again. So at first, we declared our license identifier, we declared our pragma solidity, telling the compiler that, okay, this is the version we want you to use in compiling this file. Now we declare our contract, so contract mode. Now the convention is you make use of capital letter when writing your contract name. So after that, we enter inside our contract scope, that's our contract block. Now we want to track the current mood of a user, and tracking okay, someone posted something. So now tracking the current mood means we'll be writing to the blockchain state and we'll be reading from the blockchain state as well. So now we declared a state variable, and this state variable means whatever we store here will be permanent on the blockchain storage, unless maybe you update it. but whatever you store here is permanent. I don't know if that's understood. Now, the next thing we have is a function. The name of this function is called setMove. And this function is taking in an argument. You can call it an argument or a parameter. Now, we have different types in Solidity. We have value type and we have reference type. So now this is why I said the previous workshop, for you to understand what is happening here, you mostly must have understood what was taught in the previous workshop. I believe there you were taught they taught you guys Solidity data types, value type, reference type, and all of that. So now, whenever you're working with Solidity reference types, which has to do with dynamic size arrays like strings and all of that. Now you need to pass in a location, a memory location here. So sometimes this can be memory or it can be call data. But for now, we won't be talking about memory and call data, so you won't get confused. So just know that whenever you make use of a reference type, you have to pass in a location here, which most of the time we make use of memory and all of that. So when you pass in memory here, you pass in the parameter and all of that. That's the name of the parameter you want to be receiving. And you declare the function visibility, which is, I'm using external here because I know this function will only be called outside this contract. We won't be using it inside this contract. So here now, what I now do, I now say this current move is now equal to whatever the user passes here. So it will now set this guy to whatever the user passes here. And this is how you write to the blockchain state. Then the next function we have is the function that returns. So with this function, you can view whatever you have stored on this place. So what happens here now is you get the move. So function get move, this is also an external function because we'll be calling it outside this contract. Now, since it's a view function, functions that read from the blockchain state, they call them view functions. So you have to pass in this view modifier here to tell this compiler that this is a view function that is reading from the blockchain state. And when you do this, you now pass this returns here. So this returns tells this function that the kind of data it's going to return. For instance, if you're returning a uint, you pass in, you write returns uint here. And if you're returning an array, you pass in the array you're returning here and all of that. So then here you now return whatever you want to return. And what we are returning is this guy. Any question?
Yeah, I have a question, Cass. So,
all right,
like, I know you've been referencing like the last workshop that we did when Francis took us through like the anatomy of the smart contract and everything. But I think like the problem that I'm having, I don't know, maybe like it will be similar to like others here. Like the contract that he opened up, then like he was opening up contracts from like Etherscan. So like he was already like completely built out. So like the instances he was giving us like showing us like the anatomy. What I mean by that, just like how there's a section for events, logs, and like variables and everything. But the reason I'm saying this now is like now that you're building out this contract, you know how you made mention now that after this data structure, string, like you said, current mood now in this case is the state variable. Like the confusion now that is coming is like, so like when or how do you now declare a state variable? Like when you are right, like as you're building this contract, I don't know if you get what I mean. So my problem now is like how you use the state variable in this case. Like, is this something that just comes immediately after like opening the contract here, which is mood, and after like declaring the data type?
Okay, all right, I think I understand what you're trying to say. So this is it. Like I said, I wanted to start from the basic of the basic. I can show you crazy smart contracts that you see events, you see modifiers and all of that. But I need to start from the basic of the basic. Like, let's progress from there. You get. Now, whenever you want to store something to the blockchain, like let's say you have a database of users, right? And that database in your, let's say a database in your backend application, you have a database called users. Now that database is where you write records to. Are you getting me?
Yes.
Now the database is where you write records to. And any record you write to your database in your backend application is persistent. It's not temporal. Just the same way you have your hard drive in your computer and you have your RAM. Your RAM is your temporal memory, where when you copy something, it's saved in your RAM for the meantime. Then when you paste, it now leaves your RAM and it's now pasted in your hard drive. So your database storage is your persistent storage, where you write records to. It's persistent. Now, in terms of blockchain, that storage are anything you declare in your state variable. Anything you declare in your state variable as a state variable is persistent. This is where the storage is. So if I say address now, and I say this address, I call it my address, and I say this is equal to, let me just copy my address from here and show you something. So now if I set this guy here like this, now this stuff, sorry, I think I don't need to pass in this stuff, sorry. Yeah, I think it has to just be without the quotes. Yeah. So now with this, now when you deploy this contract, this address is like this in the database. You cannot change it because I didn't write any function that will change this address. This is persistent, it's like this in the database storage. Anything you set outside a function and inside this contract scope, this is your database, this is your blockchain storage. I don't know if you understand. So it's not like the way you have MySQL or MongoDB that you connect to and you write to. No, it's not like that on the blockchain. Now, anything that is in this state level, now, you see, this is a function. This is another function. Any variable inside, for instance, if maybe I do address me is equal to this. Now, this stuff is only persistent as long as this function runs. You cannot access this again in the blockchain. This is not stored to the blockchain. But this one now that is here is not inside a function. This is the storage of the blockchain. Now, I don't want to start going into telling you things about blockchain storage slots because that's a more complex stuff. But just understand that whenever you have a variable declared inside your contract scope and outside a function, it is at state level, and any variable declared at state level is your blockchain storage.
Okay, yeah, that was like my question. So that's what I was just trying to pinpoint, like where to separate it. Where do you use?
Yes.
Like,
So,
yeah,
so this is your this is your blockchain storage.
Yeah.
So let's proceed. All right. So let me take this guy out. I don't know if someone else have any questions. Please, I need you to ask questions. If you don't understand, don't say you will read up later and understand this thing. if you read this thing, you might not understand it. So just this explanation I'm giving you will help you understand it if you're reading. So please, if you have questions, ask. All right. So now that we have this thing, we are done with this contract, because the main function of this contract is just to write to the storage and read from the storage, right? So now the next thing we are going to do is to deploy this contract. Now, to deploy this contract using Remix, so we have this, our compiler has already compiled this guy. So you see it's sticking good here, which means everything we have here is correct. So to deploy this guy, you have the fourth icon. So this is the first icon. The second icon is for search. The third icon is for compiling. And the fourth icon is to deploy and run transactions. So once you click on it, so you see that this is our smart contract. And Remix gives you 10 addresses which you can use, 10 addresses with 100 Ether, which you can use to test smart contracts and all of that. So, and with this, you can also deploy your contract on the blockchain using any, for instance, if I want to deploy this contract now on the blockchain, I'll use MetaMask and I'll deploy it on the blockchain, depending on the network I'm connected to on MetaMask. So let me open my MetaMask and show you. You can see that there are different networks here. There is Ethereum mainnet, NAMI testnet, and all of that. So if I'm currently on Sepolia testnet, if I use injected provider MetaMask here and connect this, if I deploy this contract, it will be deployed on the blockchain directly and not in our Remix local machine. So, but for now, let's deploy it on Remix local machine and test it. So if I click on deploy here and wait, the contract has deployed. You see this good here, contract has deployed. So let's click on the contract here. And now you can see this function where it says set mood. Now, if you read get mood, let's click on get mood first and see what's happening. If I click on get mood, let's click on it. So you see, get mood has returned something and it's empty. There's no, it's showing 0 string here. This will be very small, and I don't know how to make zoom this part of the Remix and all of that. So, but if you can see this, please, or you can zoom it from your own end to see it very well. So now you see that there's nothing here. But if I come here and say my mood now is that I'm happy, and I set mood here. Now, this has written to the blockchain. And if I click get mood, you see that now we have happy here. Can you guys see this? I don't know. I don't know how to zoom this part of the stuff of Remix. So if you can see this, please just let me know. Say hi.
Yeah, we can see it, but it's like it's pixelated. So I can see happy and like.
Okay.
Yeah.
So you see, we have been able to write to the blockchain state, and we have been able to read from the blockchain state. So I can also come here and say rejoicing. So my mood now is that I'm rejoicing, and I can do this, and I'll write to this stuff. And if I click get mood, you see rejoicing here as well. So this is just a simple smart contract. Now, the reason why I did is just to show you how to write to the blockchain state and read from the blockchain state as well. Now, in order to also make this so that you understand other type of data types, let's say we want to, let's rewrite this contract and make it a count contract. So I'll change the contract name to count. And here now I'm working with integer. I will say this is an unsigned integer, and an unsigned integer, I'll call it number. Let me just call it, I'll call it count. So, oh, sorry, not unit, it's uint. So I'll call it count. So a lot of times we make use of uint. And once you make use of uint, you're automatically telling this guy that you're making use of uint 256. This is the highest unsigned, the highest number of the highest unsigned integer value in Solidity, uint 256. So once you do this, you've told this guy that, okay, what you're expecting here is an unsigned integer. And now this guy is complaining because there's no state variable called current mood. So now we want to do increments here. So I just want to do this. And these increments, we are not passing in any value. We just want to increment by 1. And this is an external function. All I just need to do here is say count. I can do count plus plus, or I can do count plus equal to 1, or I can do count is equal to count plus equals to count plus 1. These are different ways you can do the same thing. Then here now, sorry, it's supposed to be increment. So I can write another function called decrement. Function, I call this decrement. And this will be also an external function. Sorry, with time, you guys will be writing this stuff like this. So I can say count is equal to count minus 1. And now these two variables, these two functions, they are just modifying this count state. This one is incrementing the count state. This one is decrementing the count state. But we don't have a function that will return the current count state for us. So we can come here and say get count. And this will be external view. Now we are returning a uint. So we are not going to make use of string here. We are going to say uint. And we are removing memory because we are dealing with value type. And this will just return count here. And we are good. So like I said, this is one way to increment count. So let's look at something. No, let's leave it. I don't want to complicate things. But now, let me just mention it so you know. The way you write your logic affects the amount of gas you spend when calling that function. So for instance, count equals to count plus 1. It's taking 21,042 gas. Now let's see count plus equal to, plus equal to 1. Let's see the amount of gas it's taking. This one is taking 21,061 gas. Now let's look at count plus plus. This one is taking 21,058 gas. So you see the other count equal to count plus 1 takes lesser gas. Let's look at it. This one is even showing 166 gas. Sorry. Okay, yeah, 21,042 gas. This is what it was showing before. So these are different ways to write different stuff. And a lot of times you think the easier one is the best, but sometimes the longer one is the best because it takes lesser gas to compile or to compute and all of that. Why is this guy complaining here? This is remix problem. So this is this about this. So let's deploy this guy again and check it out and see what happens. So I'm going to deploy this contract again. See now the contract name has changed to count. Let's deploy it. So the contract has been deployed. If I click this guy, let's get count. So current, the count is 0. Remember I said every variable in Solidity have a default state. So the default state of uint is 0. So if we say increment, it has incremented this guy. If we get count again, it's now 1. If we increment again, we get count is 2. If we decrement, we get count is 1. If we decrement again, we get count it's 0. Any question before we proceed?
I have a question, Cass. Coming back to unsigned integer. So that 256 is just something that people just specify normally instead of uint count, just put uint 256.
All right, so it's a more professional practice to add the number in front of it. Now, there are different types of, uint values. So uint 256 is the highest value you can get, the highest number value you can get in Solidity. So let me show you something. Just let me show you something quickly, so you understand what I'm saying. Please, I need other people to be asking me questions. So let me zoom this guy so you see something. Go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see this guy? Is it big enough?
Yeah.
All right. So I want to go into something called Solidity shell. So don't worry about Solidity shell. Don't worry about it. Just once you start dealing with a lot of complex smart contract and stuff, you want to make use of it. Now, I want to show you something. So type uint 256. Hope I'm using the right syntax. .max. This is the number. This is the highest number. Now, this uint 256 now, it can hold value as big as this. This is the highest number uint 256 can hold, from 0 to this number. Do you understand?
Yeah.
Now, but it's redundant. For instance, if I know that I'm not going to work with a number as large as this, why will I be using uint 256? For instance, now let's say I'm building a smart contract that will be dealing with like 100 users. Why using uint 256 is redundant, because this will consume more gas. So the best thing to do is look for a uint value that works with this. So for instance, let me say type uint 8.max. So uint 8 will give the highest value uint 8 will hold is 255. So since I'll be working with something with a value of 100, why don't I just use uint 8 here? And this will consume less gas. Do you now understand?
Yeah, I do, Cass.
So, but once you make use of uint without any number in front of it, automatically you're telling it to use uint 256.
Okay.
You get? All right. Akikia, you're the only one saying something. Other persons are not saying anything, and it's making me feel like people are not following. Are you guys following me? Please ask questions.
Yeah, we're following.
Right. Please, if you get confused, I'm expecting lots of questions, because I expect you guys to get confused. But you guys are smart, though. That means nobody is confused so far. All right.
They are very, very intelligent.
All right, now, no problem. So now these are just the basic, these are the basic contracts and the basic of the basics, all this stuff and the rest. So the next contract we are going to write is slightly above this. It will introduce a different type of data type and all of that. So the next contract we are going to be writing is a to-do contract. So whenever you learn any new programming language, the first thing you try to build is a to-do. If you learn React, you want to use it to do a simple to-do. If you learn PHP or Laravel or JavaScript, you want to do a simple to-do. So the reason why you see people doing a simple to-do is not because to-do is like the only thing to do, but to-do is what gives you a grounded background that, okay, you understand the flow of things. Because with to-do, you can create, you can update, you can delete, you can read, and all of that. So it just gives you this CRUD this thing to write to database, read from database, update database, delete database. So once you're able to understand those four concepts in a particular language, then you can start building on top of it. You can start going to building an event management system, all those different type of stuff. So the next thing we are going to be doing is a to-do smart contract. All right. So there's a recording for this video, so you can follow the recording. You write all the smart contract we just did and all of that. So yeah, so let's go to our folder, Web3 Africa. I'll create a new contract here. I'll call it todo.sol. All right. So now we have our todo.sol. Can someone please tell me the first thing to do in this contract?
So your SPDX.
Awesome. But it's not XPDX. What's the name?
The license.
Yeah, awesome. License identifier. So let's go there. So please tell me what to write.
SPDS license identifier.
MIT.
All right. SPDX license dash identifier colon MIT. So what do we do next? What happened here? Oh, sorry, my keyboard. I'm not used to this keyboard, though. I just got a new keyboard that is still messing up with my fingers. All right. So what's the next thing to do?
Your compiler.
Pragma solidity.
Okay, Pragma. Oh, this guy has already done this stuff for me. So yes. So you see this autocomplete from Remix has already given us the same stuff. So you see why it's a convention. So here you set your version, and I'm always using this guy 0.8.0. Oh, 0.8.0. All right. So what's the next thing we do?
Our contracts.
Okay.
That's, yeah.
Contracts. And we are going to call this to do. All right. So now I want us to think together. Now note that as we are writing this contract, I'm also showing you guys how to think as a smart contract programmer, all of that. Now we want to write, want to build it to do, right? So someone please tell me, what are the common entities? What are the common things of a to-do? What must a to-do have?
It must have like an object, maybe an array, something like that.
Okay, awesome. So an object, like I want to know if you're creating a software now, you want to create a to-do app and you want to add a to-do. What and what do you pass in that to-do? What are the things what if one single to-do have different kind of stuff? What are those things they have?
Might be ID, something like name, maybe.
Okay.
Maybe like,
All right. So a to-do will have title. A to-do will have description. A to-do will have status, whether it is done or undone. True or false?
True.
All right. Okay. All right. So let's just work with this data. Okay, someone said the to-do will have date. Let's add date to it. Awesome. I like this person that said date, because this date will help us to make use of something, one cool feature in Solidity. All right. So now that we have these things, in your last, so I want to be sure that you guys are actually following the word in all this bootcamp or in all this workshop. Now, in your last workshop, there's a particular data type that enables user to structure their own data type. What is that?
Struct.
Struct. Awesome. Awesome. All right. So now, because we are making use of to do, and we want to group now, what struct does? Struct enables you to group different data type together as one data type. It enables you to create your own user-defined data type. Remember, we have different data types in Solidity. And there's one thing now, there's one expo I will give you that will enable you to understand data types very well. Now, all value data types are numbers. This thing I'm telling you now, once you
come again, all words.
All value types are numbers. What are the value types? Can you name them?
Like integer.
Awesome. Wait, just calm down. Integer, right? What's the
Yeah.
next one? Uint.
Okay, int and uint, there are two. Okay.
There are many. Int, uint, keep calling. Strings are not value types.
String is text.
Bool.
I thought bool was like true or false.
Address. Bytes.
Okay.
With numbers. All these are value types. Enums. Enums. Now, all value types are numbers. Is anybody doubting that? Is anybody disputing that? Can you guys still hear me?
Yeah, we can.
Is anybody, does anybody have a contrary opinion?
The only thing I thought, I don't know, in Solidity, you know how bool, is it the same thing as Boolean?
Bool
Like
is
true.
Boolean now. Bool is Boolean.
Okay, so that's all. I was just like, if that's the case, it's not like true or false, so and doesn't have value.
True or false? What is true or false?
That's 0 and 1. So
Okay.
yeah.
Is that not a number?
Yeah.
What is an address?
But address is a string, is it not?
Address is not a string. Address is a hexadecimal number, which you can still convert to integer, and it's a number. Are you guys confused?
Or noting it down.
Byte 30. If you have something like this, bytes, this is not a number. Once you have bytes like this, it's not a number because it doesn't have any number in front of it. So it's a dynamic size array. But once you have something like this in front of it, or this in front of it, it's a number because this becomes a hexadecimal number, which you can convert into a decimal number. It's a number. Enums are number because for you to access the what is it called? The members of enums, you use 0, 1, 2, 3. So enums are numbers. All value types are numbers. So this is the best way to remember value types. Somebody say, how are enum numbers? Okay, chill. Let's declare an enum. Enum status. And inside this enum status, how do I declare enum again? I forgot it. Now, inside this enum status, let me remove this guy. So inside this enum status, you have pending. You have pending. Are they separated with commas? Okay, I think they are not separated with comma. We have pending. No, they are not separated with comma. This guy is giving me error. Oh, they are separated with comma, sorry. We have pending. We have added and all of that. Now, for you to access this enum, if you want to make use of this enum, this guy is at position 0. This is 0. This is 1. So enums are value types. Anyway, don't worry, you understand us. Let me not confuse you the more, but just know that all value types are numbers. So now we are building a to-do smart contract, right? So a to-do has let's create a struct. We are declaring our struct and we call it to-do. Now structs have the same naming convention as contracts. So if you're giving a struct name, it must start with capital letter. And if it's like a 2-syllabic word, the next word will start with a capital letter. So let's call it to do item. And we do this like this, struct. Now, the first thing we are going to do now, we need our struct title. What's the type of struct title, please? I want it to be interactive. What's the type of a struct title?
String.
Awesome, string. So string, we call it title. Now this is why I get confused between enums and struct. You see, enums, they are separated with commas, but struct, you end it like a normal statement. So that's why I get confused somehow. So no, you're not accessing the index. Edit asukwo. Yeah. So don't worry. We'll talk about that later. Let's not take every other person back. So now the next guy we need our description. What's description? String. All right, string, we say description. And we end it here. So someone made mention of we have status. So status is bool. This would return true or false, whether that to do has been done or not. And someone made mention of date. So date in Solidity is a uint, it's an unsigned integer. So we are going to make use of uint and we call this date and we end this. Are we good?
Yeah.
Yeah.
All right, so this is our struct
That's the
of.
question.
All right, yeah, go ahead.
So what if we use int for dates?
Int for date.
Yes.
You can use int for date as well. But the reason why I can hear myself. Can you mute?
Okay, let me.
All right. So the reason why you don't make use of int a lot of times in Solidity is so that you don't run into errors. Now, whenever you make use of unsigned integer, it means that this value should not have negative or positive value. It's just a number. And by the time you start having minus, you know you're already having problems. So this is like a strict way of writing your code and saying, okay, uint date, then we are not dealing with negative numbers when it comes to date. So why will I be using integer? And since I've been writing Solidity, I've never made use of integer. I've not had any reason to make use of int in my contracts. I've always been using unsigned integer because unsigned integer can never have a negative value. Do you understand?
Yeah, yes.
All right. So now, the next thing we want to do now, when we create, so let's say we have 10 to-dos or 50 to-dos. How do we hold all these to-dos? How do we hold all of them? Can someone suggest for me?
Maybe we could do an array of to-do items.
Awesome. That's lovely. All right. I think that's cool. I like that. But there's another way you can do that, but I won't be teaching that in this workshop. So let me just post it in the group so that you guys can write it out and study it. So study how to hold data with mapping and get all the data in a mapping variable using iterable mapping. So that's what we call, now I don't like using arrays a lot of times unless need be. So I just pasted something in the group. So if maybe I wanted to write this contract personally myself, I'll use mapping to hold those data. I won't use array. Then I'll now write an iterable mapping to loop through the content of the mapping and return the data, everything in that mapping. But that will be more complex and confusing for you guys. So now let's work with array. So now, since this array, remember, if you want to write an array in Solidity, you have to first of all declare the type of the value, what the array will be holding. For instance, now, if this array was going to be holding only unsigned integers, we'll first of all type uint and we put this square bracket. This is the symbol to tell you that this is an array. Then we give the array a name called numbers, right? And end it. Then if you want this array to be viewed publicly, you can add a modifier called public here. But now,
Question.
Yeah,
Question.
yeah, go ahead.
I want to ask if the only available options get multiple changes now be
I can't hear you.
Please, can you hear me now?
Yeah, I can hear you now.
Yes, I'm asking what other options do we have apart from array and mapping for multiple?
Apart from array and mapping?
Yes.
Those are the two options you have.
Thank you.
All right. So now, as I was saying, this is an array, right? And remember, before you declare an array, so declaring an array is basically this square bracket. But before this square bracket, you need to tell this guy that, okay, the values I want to hold inside this array is of type this. So now we are telling this array that the value it will be holding is of type uint. But now the array we want to declare will be holding our to-do items. So that means, and remember this struct is a data type. It's our own user-defined data type. So what we are going to do is to first say this array will be holding this data type, to be holding this data type we declared, and we'll call it to-dos. And a lot of time, array has, normally, you name your array using a plural naming. I don't know if you understand. So if you're naming your array, always make use of plural naming. So if it be holding to-do items, so it should be to-dos. If you be holding user, it will be users and all of that. Same thing with mapping as well. So when you write your code this way, once people look at your code with the naming convention, they already know what is happening in your smart contract. I don't know if you understand. Is anybody confused with what's happening on line 12? Okay. Nobody's confused. Someone wants to say something. All right. Nobody's saying anything. All right. So now we have our array and we called it to-dos. So remember that the reason for this array is so that it will hold all our to-do records here. So the next thing now we need to do is, how do we now create a to-do? How do we create a to-do? So we need a function. Function, we'll call it create to-do. Now, see the way I write my function. Function naming will always start with small letter. So function naming normally use camel case, but contract and struct make use of Pascal case. So this is Pascal case. This is camel case. So yeah, let's continue. Hope I'm not wrong. Yeah, that's it. Yeah. So now we have our guy here. First of all, this function is going to be an external function. So this function is not a view function because it's a modifying state. So it's not a view function. So we do this. Now we are creating a to-do. What do we need to create to do? Let's say we have a front end that has input fields. So and that input fields will be calling this create to do function. So we need to receive all the parameters or all the arguments here. So the first thing we are receiving is what? The title. And remember the title is of type string. So we do string. Always remember whenever you're making use of reference type, you need to pass in either memory or you make use of call data. So, but make use of call data, but we are not using call data. So I knew someone will ask questions. So whenever you make use of call data, that means first of all, call data consumes less gas. It's more gas efficient when you make use of call data. But when you make use of call data, that means you won't be manipulating that variable in your function. It's only a call data, you're only setting it. Okay. You won't be manipulating that variable in your function. But when you make use of memory, you can manipulate that variable in your function when you make use of memory. That means you can change that variable in your function. But when you make use of call data, you cannot change that variable. That's the value of that variable you're passing. You cannot change it. It must remain a call data. You're only using it for this call and nothing else. All right, let's proceed. So also, let me give you guys something that will help you very well. You see this guy, sorted by example, everything you need, primitive data type, variable, constant, immutable, and the rest. You see this storage, memory, and call data. There's data locations. You see all of them here. I'll send it here now for you. So you can use this to learn more about this guy, all these stuffs now. So you see both sending ETH, fallback function, delegate call, all of that. But don't be too fast though. You might read some concept that will confuse you. But yeah, subsequent mentors that will be taking you will explain most of these things. Yeah. All right, so let's proceed. Now, let's use memory. So this guy is string memory. Now, it's a convention that whenever you're making use of parameters, a function parameter, you make use of underscore. It's not a must. We can still make use of title here. We can still make use of title here, or you can still make use of new title here, right? Make use of new title. But normally, if you want your code to look like a standard code, like whenever you make use of underscore, it means that it's a receiving input, a function parameter that you're passing. So you do something like title like this. Then the next thing we want to receive is description, which is also a string. And this string is of type what? Memory as well. And we are also taking description. This keyboard is not disgraceful. Description. So we are not going to pass in status, and we are not going to pass in date. So we are going to make use of a global variable to set the date. and all of that. And the default status of your to-do is false unless you decide to change it. So the next thing we are going to do now here is now to initialize our structs. So there are different ways to initialize structs. There are 3 ways to initialize structs. So you can initialize a struct by doing something like, first of all, when you want to initialize a struct, you have to first get the struct data type. You get the struct data type. Then you now say, you set in the location of where you want to use this guy. So since this is a reference type, and if you're using it, you always have to specify the location here and all of that. So, and I'll call this new to do, right? So you can either use this. Let's see. Can do something like this. I don't really use this stuff, so I think the syntax is kind of a bit confusing. So you can use something like this, and still trying to remember the syntax. So let's see. Okay. Do we have something like this? Okay, you can use something like this. Then you do title is equal to underscore title, comma. You do description. Sorry, why is this guy? Description is this guy, is this description. And now, whenever you're using this type of struct initialization, you have to put in the value of all the struct members. So you now say status will be false and date will be 0. End this statement. Let's see if I'm correct. Awesome. So I'm correct with this. So let's see. Why is this guy complaining? Function state mutability can be restricted to pure. Yeah, okay, I get this guy. So now you see here now we have set our guy and all of that. And we are passing false here, we are passing dates here. This is one way to initialize a struct. This is one way to initialize a struct. But I don't like initializing struct this way. So the way I use a lot in initializing struct, unless otherwise, maybe I'm working on something that I won't be able to, maybe I'm working on a kind of data structure that other pattern of initializing struct won't work. That's when I would do this. But I don't use this a lot. That's why I'm even trying to remember the syntax. So you come here, you kill this guy here. So when you do this, you come down here. Since you're giving this guy name new to do, what you just need to do, you now say new to do dot title is equal to underscore title. You end this guy. You go to the next line, you say new to do dot description. I use some touching underscore here. Dot description is equal to underscore. I say this keyboard will not disgrace me. It's also underscore description. Kill this guy here. Now you don't need to set this one and this one. They will automatically take new dates. But remember that we want to get the time when this to-do was created, the time where this to-do was created. So there is a global variable in Solidity that you use to get the current Unix time. So what you now need to do, you now say new. That's why I say the person that made mention of date did well. New to do dot date will now be equals to block dot timestamp. So this will get the current block dot timestamp, like the current time this user is calling this function. So the next thing you just need to do, you now say to do's dot push new to do, and we have this in our array. So we have created our to do like this. Any question?
So, Cass, I have a question. And
All
the
right.
question had to do with like the to-dos. So the purpose of these to-dos now, you said like when you're working on with arrays, you have to make it like plural. That's the only reason like these to-dos is here.
No, calm down, relax.
Okay.
I'm just, what I said is, this is an array, right? What is the purpose of an array? The purpose of an array is to hold data of similar types. As far as Solidity is concerned, in other languages, you can hold data of different types. You can hold string, integer, and all of that in one array. But in Solidity, an array holds data of similar types. Are we good?
Yeah.
Now, if an array is holding data of similar types, what is a good way to name that array? Let's say an array is holding users. You understand? It's holding different users. What's a good way to name the array so that anybody that sees this contract will automatically know what this array is doing without even going through the functions?
You name it users.
Simple. That's why I said that you can remove this. You can call this anything. You can call it Akikia. It will still work. All you just need to do is come here, copy this guy, and change it with this guy. And change it to this guy. It will work fine. But for people to, now you're not just writing contracts for yourself. If you write contract, you need people, when they read your contract, they should be able to sync with what's happening here without stress, without you populating your contract with so many comments. You get?
Yeah, I do.
So that is why we make use of that to do's.
Okay. So
Yeah.
like lastly now, you know, okay, this push instruction that you gave it now is just like, how will I put it now, like the naming aspect to it. These to-dos are pushed on new to-do.
All right. So this new to-do you're seeing here, it's the new to-do we have created. This to-dos is an array. This push is the same thing you have in JavaScript, push method to push something, to push an item into an array. So this is your to-dos array. You're calling it dot push method. So it's pushing this new to-do that you created here. And remember this new to-do, you have already set a title for it, a description for it, and a date for it.
Yeah.
You understand? So you're now pushing it into this guy, into this array.
Okay.
Is that clear?
Yeah. Thank you, Kat.
Awesome. Now, I would have just used this opportunity to talk about events, but well, what's the time? Okay, we started by 5 and this is 7. All right, so we have like 1 hour to go. Okay, so now events are mostly used. Should I talk about events? It's not part of this curriculum, but whenever, no, let's continue. Let's leave events. You deal with events in subsequent classes. But just for you to let it just stick in your head that you use events mostly whenever you're in your state mutating functions. Any function that is writing to state, any function that is updating state or changing the storage value, it's a state mutating function. So that is where you use event. You don't use event in view functions or pure functions, functions that read from storage. You don't use events there. You use events in functions that write to storage, that write to the blockchain storage, which means it's updating the state. That's where you use events. So this is a good place we can use an event and all of that. But just for the purpose of staying within the scope of the curriculum, let's not talk about events. So now we have created our to-dos, right? So the next thing we want to do now is to get our to-dos that we have created. So we create a function, call it get to-dos. And this function is a view function because it's reading from the blockchain state. So it's not taking any parameter. So we want to, so I like making use of external because I know this function, I'm only calling it outside. I don't have any need to make it public. Public function consumes more gas than external function. So let me show you the hierarchy of gas consumption. Public consumes more, followed by external, followed by internal, followed by private. So, and me writing a smart contract, I'm always conscious of gas optimization. It's subconsciously, I just want to optimize gas. With time, you understand that. So since this function, I'm only calling it outside this contract, there's no point making it public, unless maybe I have in mind to call it outside and also use it inside. That's when I'll make it public. So just to optimize this stuff, there's no need making it public because public functions consumes more gas than external functions. So now I'm making it external. So this is a view function. So it's going to be view, external view, and view function returns something. So you tell it returns. And what are you expecting this function to return? You pass it here. So this function is supposed to return an array, and it's returning this array. So it's returning an array of to-do items. So you pass it here. It's returning an array. Where's my square bracket? And remember, whenever you're returning anything that is not a value type or is not a primitive type, you have to specify this here. So what are we returning? We are basically returning our to-dos. And that's all for our view function. Oh, sorry. Now, there's something else I will show you. Just know it, because with time, you make use of it. Now, if you've been writing, if you're a programmer, like you're writing JavaScript, Python, PHP, all those other Node.js and the rest, you know that whenever you make use of return, nothing happens here again. That's where the code ends, true or false. All right. Now, anything you do under here now becomes an unreachable code. It becomes an unreachable code. You can't, once there's a return, your function ends where that return is. Nothing, every other thing below here will not run. But in Solidity, you can return something and still run functions. That is where you make use of make use of named return statements. So here now you can now call this. Now, remember I said whenever you're getting something, you make use of underscore before the stuff. But whenever it's an output, if it's an output, you can call this to do, and you put an underscore in front of it. This way, it means something, this is going out. It's something that is going out. So all you just need to do here, you say to do's. You have already returned it by doing this guy. You just need to do, say to do's is equal to this guy, and you're good. You can still write things. You can write other logic here and they will run. You write other logic here and they will run. So, but just know this, just know this, because in the process of writing smart contract, sometimes when you start reading contract like Uniswap contract, you see all these concepts and all of that. But just know this. I just want to chip it in. Don't worry about it, but you encounter it later. So let me remove this guy here and make use of our return statement back. So let's return this guy. Now we have returned our to-dos. So please, I don't want to be the only one thinking of the functions to write. Can someone else tell me what other function we need to write for a to-do app? It's a to-do app. You guys are not computers now. It's not garbage in, garbage out. Before we delete, there's something we need to do.
Update.
Okay. So we want to update to do, right? So let's write a function. Update to do. Now, what do we need to update it to do? These guys, I don't want, if I can just be writing this stuff and be going and you just be looking at me, but I want us to participate in this. Let's go. What do we need to update it?
You can update the title and description.
We can update the title and description. How do we get the title and description from an array?
Use the index.
Awesome. Now, you see, this is how you think. So that's why I said, in the process of writing contract, I'm also showing you how to think. Index. So our index is what? A number, right?
Yeah.
So we want to update the to-do title, string, memory. So I'll be a bit fast. String memory, call it new title, and we also want to update the description, and we call this memory also, and we say new description. Why is this one complaining? String, memory. Why are you complaining? String.
There is, when you look at that string memory, there's no comma. String memory, and we have
There's no comma. It's not supposed to have comma. I think it's good. Don't worry. This is Remix misbehaving. It's Remix that is misbehaving. Don't worry. It has already showed good here to tell you everything is fine. It's Remix that is Johnson itself. So now we have our index. So first things first, to do's our array into the index, which is this guy. Index dot title is equal to our new title. This one is a very simple function. It doesn't need stress. Simple function. Next thing again, to do's into index dot description is equals to new description, and we are good. That's all. Oh, okay. Index, not IDEX. Yeah, we are good. You have updated your to-do. Simple. So the next thing we want to do, we have not talked about our status. Let's say you're done with that task and you want to update the status. You're not updating dates now. Why are you updating dates? Date only holds the time the to-do was created. If you want to update date, it's simple. If you want to update dates, all you just need to do, copy this guy, put it here, index date, set it to the current block.timestamp. Block.timestamp returns the current time. Block.timestamp. If you want to update dates, you do this and you're good. But there's no point updating dates. You just want to change the title and the description. So I think this is redundant. So take this guy out. Yeah, so this is our stuff. So the next thing we want to do is to change status, the status of our to-do. Let's say I'm done with that task. I want to change the status to be true, like done. This thing can either be done or, you understand? So, or completed, anything you want to call it, but let's stick to status. So now here we now say, this will be function updates to do. I want to be very fast, update to do status. So this update to do status will just take in the index of the to do. So uint underscore index. This is an external function. So all you just need to do, go to to-dos into that index. And you say dot status. Now I want to perform one magic here. Is equal to not to-dos into index. Ask your question as I'm finishing. Just be asking your question. Why am I doing this? I know someone wants to ask that question, so just ask before I proceed. If you don't ask me, I'll proceed without answering. Any question? Do you understand what's happening on line 33?
So you said not to do's. What do you mean by not to do? Like, are you invalidating the to do's or what?
Now, so when writing smart contracts, try as much as you can to make life easier for people. So see the name we call this thing, update to do status. We didn't say mark as done. It's called update to do status. Imagine now you mistakenly change a to do status to be done. And you now realize, oh, you're not done, and you want to change it back to undone. That is why this function is very important. So what happens here is to do dot the index and dot status is equal to not to do status. That's the opposite of what was there. So this guy, the current status now is false. So if you're updating this status, the inverse of false will be what? True. Do you get it?
I have another question.
You say?
I have a question.
All right, go ahead.
Now, why can't we combine the functionality of, the function of update to do status and update to do? Why can't we update that status inside the same function?
Why can't we update this one inside the same function?
Yes, the status.
We can. Now we can. So remember, first of all, let's go back to this. I'm beginning to enjoy this class. So come back here. Now, look at this stuff, smart contract design pattern. Simply refers to how a smart contract developer chooses to design the flow of their logic. You can do anything you want. All you just need to do is understand how to do these things. Provided you can think it, you can code it. Anyhow you want this thing, you can do it. But me, I choose to do it this way because this is my design pattern. This is what I choose to do. You can simply, and why do you even want to collect this thing here? Or you want to be receiving, you come here, you now say, you receive something like a bool here, and this bool, you call it a status, right? So from your front end, you'll be passing through or 1 or 0 here. So what you just come here to do is you do something like this, to do dot what is it called? Dot status is equal to this guy. Equal to this guy, Abi. It still works. If it's what you're talking about, it works very well.
Another question.
For me, I don't want to do this. I don't like it. I think this pattern doesn't make sense.
I have another.
Yeah, go ahead.
Thank you for reminding me of that slide and bringing me back to that slide. But I want to think somehow. When we are looking at, you said something earlier, when you talked about what you will use, because of naturally your instinct helps you to do that because of consumption of gas and stuff like that.
Sorry.
And
go ahead. Come again. I think your line broke for a second.
I'm sorry, can you hear me?
Yes, I can hear you. Yeah.
Okay, I said, no, you talked about something that your instinct lets you do some things because of gas consumption.
Yeah.
Now, if we go by this freedom that Web3 is giving to us, Web3 operating, are we not?
Wait, I don't know. There are some things you say if you go by what, this freedom or this free weight. What did you say?
Yes,
I
like
didn't hear
from the slide you referred to. If we go
Okay,
by that freedom, that we are bound. Sorry, we have so much freedom to do whatever we like.
Yes.
Would that not be causing a little trouble of gas consumption? Because I think if we have some best practices, good practices, it could actually guide us to do more of gas consumption, something like that.
All right. So when we talk about freedom in terms of writing code, we are talking about you, the programmer. You have the freedom to think whatever you want to think and write whatever you want to write, provided you can think it, you can write it. Then, secondly, as a smart contract programmer, whenever you're writing any function or you're writing your logic, you have to be gas optimization conscious. In the sense that if you're writing your code, you have to ask yourself, are there better ways to write this thing? Are there better ways to do this thing? Are there better ways to do this thing? You understand? But this stuff you pointed out that we should add status here, it has nothing to do with gas. It's redundant. To me, it's redundant. You can have your own design pattern. Maybe your front end, you want users to be passing, have the ability to pass in their status or their, you can add it. But with this guy, this update status, it's like a toggle effect. If you click on it, let's say you have a button, when the status is false, that button will be done. When you click it and it changes the status to be true, that button will be undone. Something like a toggle button. That's why we have this function here. That's what I'm seeing. So whatever you're doing, it's your design pattern. And as you're thinking of your design pattern, you're also thinking of better ways to optimize your code so that it's gas efficient. Is that clear?
Yes, that's clear. Thank you very much.
All right. Please, let's proceed. We don't have much time again. We're supposed to write 3 smart contracts, and the third one was the one I wanted us to write. So it's a progressive thing, but nevertheless, we can stop with the to-dos, and I'll give you that one as assignment. So now we have this guy. So is there anybody that doesn't understand what's happening on line 33?
So you said the reason it came out like that is because that's the only plausible option. If it's a bool, and we said just like the question I asked before is 0 and 1. So if it's going to update, it has to update to the opposite.
To the opposite, yes. That's why I did this. So if you click update status, if it was false before, the new status will be true. And if it was true before, the new status will be false.
So I'm guessing that's what the exclamation mark in front of the to-dos.
This exclamation mark means not. This is called negation. It's a negation sign. So what's the opposite of the previous status? This is like the opposite. It's just like not, when you say something is not this thing. So the status should be the opposite of the current status.
Yeah.
And yes, that's what this thing means. It's a negation sign. All right, so let's proceed. Now we have our update status. Let's get a single to do. Let's say you want to view. Remember, you can get let's say you're writing a blog, you can get all your blog posts, but you want to view one particular blog. So you need to view that one. So what am I doing? All right, so let's write a function to get to do. So this one is get to do. So it takes in the index of the to do you want to get, index, and this is going to return, sorry, what am I doing? External view return. So this one is not returning an array, right? So this one is just returning what? It's returning just the struct. It's returning just one item. So we're going to return this guy. What are we missing? What should we put here again?
Memory.
Awesome. Do we need memory here? Memory, awesome. I like as you guys are following. So all we just need to do is return to-dos into the underscore index. It will just return that one to do, and we are good. See, this thing is not hard. This is very straightforward, like so awesome. So let's delete to do function. Delete, not delete, delete to do. We are taking the index because that's the only unique identifier as far as we are concerned. External, run this guy. Oh, sorry, I didn't put in the type. View it. So run this guy. So what we just want to do is delete. And we delete to do's. To do's into the index. Why is this delete not highlighting? Okay, this guy has already told us it's correct, so we are good. Now, before we proceed to compiling this function, this contract, I want to ask you guys a question. How many functions do we have here? 1, 2, 3, 4, 5, 6. Now we have 6 functions. How many functions here need an event?
All right, come again.
We have 6 functions in this contract as a whole. How many of these functions needs an event?
4.
Okay, one person. Who has another answer?
So I would say 3.
3.
Yeah.
Okay, we have 3. Who else?
3.
All right. So Ede Tasukwa, why did you say 3?
Okay, because when you are talking about adding event listener, you talked about modifying the state.
Event listener.
Event function.
It's not event function, it's not event listener, it's just event.
Okay, sorry. Sorry. So you talked about modifying the state of the block in the blockchain. So from the function, I think there are only three from my own understanding of it: the create to do, the update to do, and the update status. I think those are the three that are modifying the state of the block.
What about the delete to do?
Oh.
All right.
Okay.
So the person that said 4 is correct, actually. I think we have more than, we have 1, 2, 3, 4, 5, 6. Yes, we have 6. So this one modifies state, this modifies state, this modifies state, and this modifies state. So we have 4 functions where we can make use of events. So yeah, that said, let's compile our contract. So this is our contract. It's already here to do. Let me deploy. Contract is already compiled. I'm deleting this count contract here.
Sorry, Cass, you said the last one was delete, yeah?
Yes, yes. So I've compiled this contract. I really hope you guys will be able to see this place, because this part now is, we want to test this contract. In a way, I'm also showing you how to test smart contract.
Please, try dragging the left plane if it will zoom. Sorry, the right plane. I don't.
It's not zooming. It's just getting white, but it's not zooming. I don't know how to zoom this part. I don't know how to. Let me see. I don't know if I click zoom. Okay, I think, yeah, it's zooming now. Awesome, awesome, awesome. It's zooming now. You see, we learn every day. I just learned something. All right. So now this is the create to do, right? We have deployed our contract. This is the create to do. Before we test, let's check our get to do. You see, everything is empty, 0 tuple, everything is empty, and empty array. There's nothing here. Let's check index 0 of our array. Nothing. The contract is reverting because there's no index currently. The array is empty. There's no index 0. So this contract is reverting. That's why you're seeing this transaction has been reverted. All right. Now let's create a to do. I'll click here. So first thing, the name of this to do is read Solidity docs. I'm creating to do for you. This, just read it. What am I doing? Okay, just read it. Now let's transact. This transaction has gone. So if we come back to get to do, you see, read Solidity docs, just read it. False, this is the current timestamp. Now let's create another one and say, talk about Solidity and just say it, and we transact. Now we have transacted. Let's get to this. You now see we have read this, talk about Solidity, just say it, and all of that. Now, according to array, the first one is at index 0. So let's put 0 here and get to this. You see, read Solidity, this. And if we also make use of this here, put index 0 here and get it, it returns it, read Solidity, just read it, blah, blah, blah. So if we put index 1 here, it will get the second one, and we are good. Now let's update status. First of all, let's update our the one with the index of 0, let's say it. Want to eat noodles. So I want to use something that will stand out. We have updated it. So let's get it again. You see, eat noodles, false. Are we good? Are you guys seeing this stuff?
Yeah, we can.
All right. Now let's update our status. So you see that, let's go back to this guy. Let's go to index 0. So we'll be seeing it very well. So that's changed to this guy. So false, this guy is false, right? Let's update status for index 0. Index 0 and say update status. That's updated. Let's check it again. You see it's true now. Let's update the same status again and check. It's false. So this is a toggle guy. It's toggling this stuff and all of that. Now let's check delete. We want to delete the one at index 0. Let's delete this guy. That's deleted. Let's get index 0 now. You see everything has been removed. Now there's one thing I want to tell you. Delete in Solidity doesn't delete the content of the array. Delete, when you're deleting something from an array, it doesn't delete the index. It only deletes the value. It sets the value to the default value. That is what delete does. So there's a way you can do delete, but now you have to do array shifting, and you have to study about array shifting, or maybe the subsequent methods that will be teaching you will teach you how to do array shifting. So you do array shifting to actually shift. When you delete something from an array, you shift the content, so it will remove everything from that array. So that is how that is done. As you can see, we have completed our to-do contract. Are we good?
Yeah.
Any questions so far? So we have like 24 minutes to go. So I can quickly introduce us to our staking smart contract, which is the Oga Kwata of what we are going to do today. So I'm actually enjoying this. So I hope you guys are enjoying it as well. All right. So yeah, any question before I proceed?
I have a question, sorry. So you said that the delete will only remove all the values.
Yeah.
After the delete, can we now make use of this, of the old stuff? Can we still make use
of the index?
Yes, of the index after the
let's check. I've not tried it before. So the only thing we can do is to update. Let's try updating it and see. You updated. Let's check it again. It worked. So you can update it. Exactly.
Yes.
All right. So yeah. So yeah, let's now look at staking smart contract. This staking smart contract is one of, now when you know how to write staking contracts, it's one thing in DeFi that you encounter a lot. Staking. People like protocols like what is it called? Synthetics, they make use of staking. Protocols like what is it called? Compound, Pancake Swap, all these guys make use of staking and all of that. So staking, knowing how to write a staking contract is one sweet thing that will really be handy for you. So let's work on this stuff now. So what's the first thing we will do for the staking contract?
Your license identifier.
Okay. All right. So the contract we want to write, right? This is what I want us to do. Let me just write it in the chat section in case we don't finish it. So write a smart contract where you can stake an ERC20 token to earn rewards, but you must have a particular NFT for you to be able to stake. Please, this is it. maybe someone can send it in the Discord group. This is the contract we want to write. Now, the reason why I love this contract is because it will help you understand how ERC20 token works, and it will help you understand how ERC721 works. That's the standard for NFTs and all of that. So in case we don't finish it here, this is your research. This is what I need you guys to do, like, and do it, submit. You can do it and post it in your GitHub gist. So let me show you GitHub gist and how you can post your code in GitHub gist. So go to gist.github.com. So the code you post in your GitHub gist are codes that just one file. You don't need to create a repo for them. You understand? You just put it in your GitHub gist and send me the link for me to look through it. So this is my GitHub gist, and these are all my gists. So these are different stuffs. I can just write and push them here. Oh, sorry, my own gist. This is other people's gist. My gist, sorry. So this is my gist and all of that. So if you want to create a gist, you can just come here, click on this plus, you paste your code, here. Then the name of the code, the name of the file will be the name dot the extension. So for solid to be dot so. So post it. When you create it, you send me the link. I need to see what you guys did. If we are not able to finish this contract and all of that, I'll need you guys to complete it. All right, so that is that. All right, let's go back to our contract. So the first thing first, oh, let me just copy this thing. It's not time to continue typing. All right, let's go here. Awesome. So I'll call this contracts staking. Oh my goodness. So we said, I would have loved us to be thinking together, but let's see. Now we said we want users that, okay, let me just do this. I need to bring this stuff here so that I'll be seeing this stuff. So write a smart contract where users can stake an ERC20 token to earn rewards, but you must have a particular NFT for you to be able to stake. Awesome. So how do we know that particular NFT that users must have before they are able to stake? Now, the first thing we need to do here is we need to set an address, because NFT is a smart contract and every smart contract have their own address. So we say address, we want to make it public so that people can see it, and we call it required NFT address. I want to give it a name that will enable everybody to understand. So this is the address of the NFT that we need for us to be able to stake. Now, in our stake, for us to be able to track user rewards in our stake, we need to track the amount the person stake and the time that person stake. So which means we need a struct that will hold the stake of a particular user. So now we have a struct. This struct name is called stake. And this struct, we hold what we call UINT, stake amount, or we can just call it amount for simplicity. You understand? We can just call it amount for simplicity, but just so that, you know, those of you that will watch this video later, you don't get confused. We call it stake amount. And here now we want to hold the stake time, the time this user stake this stuff, because this is what we'll be using to do our calculation. Right? Awesome, awesome, awesome. Now we have our stake amount, our stake data. So now we need something that how do we track a user and the user stake data? How do we track a user and a user stake data? And all this while we have been dealing with smart contract, we have never used mapping. Now, with mapping, once you understand how mapping, array, and struct works, you can write any smart contract in this life. Trust me. These are the three things you need. Because for you to handle complex data structures, you need mapping, struct, and array. Address, uint, all those ones are just basic data structure that just hold one value. But for you to handle complex data structures, complex smart contract design, you need to know how to use mapping, arrays, and struct. Now, a mapping, whenever you want to track data or records of a particular person, or you want to track records of a particular identifier, that's where mapping comes in very handy. So now we want to track record of a user, a particular user. Now we have to make use of mapping. And that mapping will have a unique identifier. And as far as blockchain is concerned, the unique identifier of a user is the user's wallet address. So we have something like this mapping, you say address. This address will now point to what do we want to track for a particular user. We want to track the user stake. And we are going to call this stakes. Any question before we proceed? What's the time? 7:47. Any question before we proceed? Please ask me question. We are using mapping for the first time, so I expect questions.
So what we're tracking now is like the individual's address and the amount that he staked.
This is what we are tracking. Every individual, as far as this smart contract is concerned, anybody that interacts with this contract has a unique identifier. Imagine your database of users, and once you have a user table, you have a user ID. And anytime you want to get record of user, anywhere that user did anything, you make use of the user ID. Now, this mapping is that database you use in tracking user records. With this address now, it can hold the stake of this user. This can hold multiple stake. You can hold stake of myself, stake of you, stake of any other person. If you want to get the stake of a particular person, all you just need to do is pass in the address. It will return the stake of that person. And the stake holds the amount and the time that person staked. This is now that database. This is that database we are talking about. It's mapping. And mapping is like the powerful guy in this. With mapping, you can, let me show you something. With mapping, I can do something like mapping of a user. Whenever you see me with address, know I'm talking about a user. Of a user to another mapping that maps a uint to another mapping. No, let me leave it at 2D mapping that maps a uint to stake. Now, whenever you make use of this type of data structure, right? Sorry, we call this user stakes. Now, whenever you make use of this type of data structure, you're trying to say one user can have different stake And this ID now, this uint now will serve as an ID of a particular stake. That means this user can have a stake with a particular ID. This same user can come again, you have another stake with a different ID. So a user can have multiple stakes if you use this type of data structure. And you can still extend this thing to even a 3D mapping. This is a 2D mapping, a mapping and another mapping. You can extend it to a 3D mapping. That is why I said your ability to write complex data structures is dependent on mapping arrays and structs. So let's remove this guy. Don't worry, as you progress, you will know when to make use of 2 or 3D mapping. So before we proceed, let me just quickly show you something. There's a smart contract I wrote. It's a staking contract, and it has to do with multiple rewards. So atomic staking, multiple rewards contract. Let me just show you guys something quickly. So you see this is a struct of duration finished at, updated at reward rate, reward per token. This is a mapping of the reward. Now let's look for this other guy. Now look at this mapping. This is a mapping of user to a user staking position. I think this is just a 2D mapping. This is not the one I'm talking about. This is the one I'm talking about. This is a 3D mapping, a mapping of address to a mapping of ID to another mapping of this. So you can use different types. Once you understand mapping, there is no limit to what you can do. So let's continue. So now somebody said, I don't understand line 12. All right, editor. Do you still don't understand it, or have I been able to explain it well while I was talking? What was the time? 1952. We have 8 minutes. Hello, Edit. Can you hear me? Hello? Can you guys hear me?
Yeah, we can.
Okay, is Edit still on the call?
Yes, we can still, I can still hear you.
All right. So we don't have much time. So now this is what this guy does. So it tracks the stake of a particular user and all of that. So now let's proceed. Now the next thing we are going to do, we are going to write a constructor. I'll tell you what constructor does. So a constructor is a function that runs once, immediately when you're deploying this contract. The constructor runs only that time you're deploying this contract. It doesn't run again. So now this constructor is going to take in a parameter of address, and this parameter is taking the address of our required NFT address. So you now do this. So what this constructor is going to do is just going to set this guy to this guy. So you say equal to this guy. So that means when you're deploying this contract, you have to pass in the address of that NFT. For instance, I don't know if any of you know about board 8. So let's say I want users to own a board 8 before they stake on this contract. I'll pass in board 8 address here, and it will set it while it's deploying this contract. And if a user is staking and they don't have board 8, they won't be able to stake. So just before time elapses, let's write our stake function. That's the only function we'll be able to write. You can complete the rest of the function. So now we want users to be able to stake high. Oh, we will need to work with, so, you know, we talked about interacting with this thing. So we need to import. I don't want you guys to get confused. Okay, I think for the purpose of time, let's just stop here. So the rest of the stuff will be as an assignment. So I need you guys to, how many persons do we have on this call? We have, apart from 3 persons, we have 1, 2, 3, 4, 5, 6.
13.
13. Now,
Yeah.
13. Is it with everybody or just minus the 3 persons?
Minus the 3 of us.
Okay, so we have 13 persons, right? I need you guys to do research. Write using this stuff I wrote here. Write this contract. There are resources online. Read, scavenge the web. Look for how to write a staking smart contract, a gated NFT gated staking smart contract. Your search on Google will be how to write an NFT gated staking smart contract. Now that NFT gated means you need to have an NFT before you'll be able to do this thing. How to write an NFT gated smart contract in Solidity. You can ask ChatGPT this question, it will give you answer in Solidity. This is what you use in doing your research. You get good answers with this. So I believe with this, we have come to the end of today's class. So it's time for questions. Start bombarding me with questions you weren't able to ask earlier. Let me even open ChatGPT and see. We have like 4 minutes.
If you have questions, please unmute your mic, please. Okay, if you don't have questions, just unmute your mic and say something. Say you don't have questions.
We don't have questions.
All right, so
let me understand everything.
Please ask your question, please.
I don't have a question. Anyway, for somebody like me, I think going back to the video again, studying very well would bring more of, and I should be able to use probably the tools we have, Google, ChatGPT, or our mentors here to get whatever is disturbing me. So that's why most times I don't have questions here.
No, you need to ask questions here. You need to ask. See, I'm telling you from experience. Let me tell you from experience. There are certain things you ask. When you ask those questions and I explain it, they stick. Like, I know what I'm saying, Shad. Maybe I might not know how well to explain it.
I want to ask a question on NFT address.
Yeah.
Yeah. So I saw when you did require, if it does not match, it's going to revert the transaction, something like that.
Where is that?
I don't really understand that NFT
Where is that?
address. Is it
when you said board ape?
Okay, yeah. Why I said board ape?
No, it's not even board ape. Is it that NFT address? Is it the address of like the NFT contract? That's what.
Yes. That means you need to create an NFT contract. When you create that NFT contract, you get the contract address of that NFT contract. Then when you're deploying this, your staking contract, you pass the contract address there. So now with that NFT contract you've done, you need the interface of an NFT contract, which will enable you to interact with the function. So this thing will help you understand how to do contract interaction and how to do gated. What is wrong with ChatGPT now?
So that interface is just like the contract API.
Yes, that interface will enable you to interact with any function of that particular contract. So for like NFT now, NFT has something like a balance of. So you will do IERC 721, you pass in the address dot balance of that user. You check if the balance of that user is greater than 1. If the balance of that user is greater than 1, that means the user has that NFT. The user can now stake. But if the balance of that user is equal to 0, you revert. You don't have this NFT to stake. Something like that. I don't know if you get. I've already started giving you expo.
Sorry, the token we are donating, is it ETH or we are creating our token?
You create an ERC20 token, not ETH.
Okay.
You create an ERC20 token. Oh, ChatGPT. I wanted to show you why you know how to use it. Small thing. It's not complex.
Sorry, Cass, I have a question. That stake struct, like,
yes,
will it keep incrementing per the number of stakes I make, or how will it be like? What will it be like?
So stake stake struct doesn't increment. Now, let me explain. Struct is just like a container. Struct is a container that just structures your data. This is where everything happens. When it depends on how you actually want to write your logic. So if a user is staking, for instance, function stake, let me just do small expo for you. Function stake, you're taking, what are you taking? You're taking in uint amount, right? And this is an external, this expo I'm doing, I don't like it. I want you guys to explore, but let me just give you guys, you do something like this, right? Now, this is a stake. So what you do here is you just come here and say, so first of all, you initialize your struct. Let's say this is our mapping. So our mapping is stake, and this stake into the user address, which is the msg.sender. Okay. So come back here. So what you just need to do is get our struct. I'm currently trying to do struct storage stake is equal to user this thing. So this guy dot, what do we call this guy? We call this guy stake amount. So user guy dot okay, yeah, we are correct. So it's equal to this guy. So what we now need to do is just say state, right?
Yeah,
dot, what do we call it? Stake amount. Yeah, it's equal to the amount we are receiving here. So, but now we don't want to do equal to, because if we do equal to, what if I want to stake again? It will just override the previous listing. So we'll just do plus equal to here and equal to this amount. What is this guy complaining? He's saying this declaration has the same name as another declaration. Okay, let's just call this new stake. Yeah, this should work. So call this new stake dot this. So this is fine. So now you see what you did there. Stake images of sender. Images of sender means the person calling this function. And you now say new stake dot amount, which is this guy here, because this mapping is returning this struct. So that means with this, you can have access to whatever is inside here. So the stake amount is equal to the amount this person is passing. So you increment it. But now if you want, this is not what you would do. I've not done the NFT gating. Normally, if I want to do NFT gating, I'll do it here. I'll do something like require that. You understand? IERC 721 into IERC 721 into this address. That's the NFT address. Dot balance of msg.sender, who is the person calling this function, msg.sender, is greater than 0. You understand? Else, I'll say you don't have required NFT. Simple something. It's very simple something. And you're good. But now this thing is complaining. You know why it's complaining? Because I've not imported IERC 721, which is something I'm supposed to import here. So now do your research. I've already written the function for you. Do your research. You get. Are we good?
Yeah, well, good, Caps.
All right, so it's time. This is 5 minutes past time. So yeah, if you leave me, I will talk till 11 o'clock. So please don't leave me. Let's end the meeting.
Yes, so I beg.
Cause wants everybody to run away at this point.
So, all right. So yeah, that's it. So I guess no questions again.
June, July, August.
Sorry, Cass. Can you hear me?
Yeah, I can hear you.
Is there anything like
All right, Cause are you done?
Yeah, I'm done. No, someone is asking a question. Yeah, let me hear you.
All right. So someone is asking when are we sub? Say when are we sub?
So you have, when is the next workshop? Hello.
Next Monday.
Next Monday. So
yeah,
the deadline for submitting this stuff is on Thursday. Today is what, Monday. The deadline is on Thursday. By Thursday, I expect everybody. Some people can even submit. This thing is this content. This thing is everywhere online. So just what I need you to do is research, understand it, write the smart contract, deploy it, test it, make sure it's working. Post it on your gist, your GitHub gist. Send the gist link in the group, in the, where is it? Send the gist link here. Send the gist link, Send the gist link in the group. Now there's something I want to teach you before we go ahead. Just last thing, sorry, because this might be your last contact with me. So let me just show you that stuff before we go ahead. So it will help you. It's helping me. So this is what I do, right? So this is my personal storage. Can you see this? This is my what is it called? This is my my own channel on Discord. So test channels. So I have Git commands, npm, algorithm and data structure, founding resources. Now these are resources I use every day. I use them a lot. So I just created this stuff where I can easily, this is Tailwind Next.js. So if I open this thing, for instance, protocols to study, you see, these are protocols like Compound, Uniswap, V2, Curve, all of this. This everything about Ethereum, resources for Ethereum. This is Foundry. This is Cairo, Stacknet contract. These are hacks, recorded hacks that have happened on the blockchain. So I keep track of most of them. This is for Diamond Standard. This is Solidity Resources. So you see this stuff. If you do this, you see all those links we are sending in those groups, you will need them tomorrow, next year, every now and then, because you can't remember all these things. So you see, as I'm structuring all this, anytime I want, so this unboxing EVM storage, understanding layouts, this, so different stuff. This for library, when I learned about library, and if you see the date when I posted all these things, you see a lot of stuff about them. And all those things, algorithm and data structures. So I just want to show you this stuff. It might be useful for you. Create a Discord channel for yourself and keep track of everything and all of that. Because yeah, we forget, there's a lot of things you can't remember. So with this, you can quickly navigate and check them out. So that's what I wanted to show you. So thanks, guys.
Thank you so much.
Thank you very much.
You're welcome. All right, I'm done. I'm done.
Thank you very much.
All right, thanks, boss.
Can anyone hear me?
Yes, I can hear you.
Yeah.
Okay, so I've not been able to access the previous video. Is there anyone that can point me to where I can get them?
What's your name on Discord?
Lawrence.
What do you say?
Lawrence.
Please, I type it in the chat box so I'll tag you on Discord.
I'm sorry, I should do what?
type it in the chat box so that I'll tag you on Discord.
Okay, I will do just that.
All right.
Thank you.
Okay. Thank you so much, everybody. Thank you so much, Kaz.